Hello and welcome to the TranSpec technical webinar. My name is Dr. William Mortimer and I'd like to thank you for joining us. The webinar has been put together to show you the cutting-edge technology of TranSpec Raman. Today I will talk about the background of TranSpec, why it was designed and explaining the fundamentals and how the individual parts come together. The features and benefits of TranSpec will then be discussed and how this can be applied to the plastics industry, followed by a run-through demonstration of TranSpec in use. This will then be followed by an outline of the future plans and how we want to include our customers in this before we conclude. We then welcome any questions that you have and we'll do our best to answer them at the end of the presentation. If you think of any questions during the presentation, you can use the question box on your webinar toolbar and we will answer them at the end of the presentation. Gnosis is a research and technology company. Its origin was as a polymer research centre within the University of Surrey, where for 12 years it was industry application focused. We commercialised 4 years ago. The expertise has been focused around materials, particularly resins, plastics and composites, looking at additives such as FRs and nanoparticles, as well as the functionality of materials through property control. Gnosis offers a variety of roles from consultancy and research programmes to analytical services and method and instrument development. Our experience with many leading companies in the materials industry, along with our instrument development, led us to design TranSpec specifically to meet the challenges that face the plastics industry, particularly compounders and master batches. It is vital for businesses to be able to offer its clients an audit trail and to have confidence in the incoming and outgoing materials through QA methods. Formulation optimization is also vital for cost savings and optimal performance. The ability to demonstrate good product stewardship and integrity will not only achieve material and process cost savings, but also make you more reliable to your customer. The principle that differentiates TranSpec from other devices is how we generate high quality data and then turn that data into knowledge. We believe in maximising the amount of knowledge you can gain from your data. Data that uses molecular vibrations gives information relating to specific compounds, functional groups and their interactions with the environment. The most powerful and rapid tool for this is spectroscopy. Both Raman and infrared-based devices can utilise the TranSpec principles. We have found that Raman gives the best overall package for the plastics industry, and thus we suggest TranSpec Raman to compounders and master batches. However, there are cases where wide wavelength may be useful, e.g. if colour is also of interest. In both cases, we use the latest spectrometers to get the best quality data. How do we turn the Raman data to knowledge? We first build libraries of spectra for plastic formulations. Techniques in the past have stopped at this stage with very limited results from overlapping spectra, for example. TranSpec goes further. It uses multivariate statistical analysis that uses all the spectra, and this data is then regressed against known material characteristics. This way we can pick out the information relating to the target parameters only, such as concentration of additives, properties, processability and performance. The added benefit of this type of system is the database and models can be constantly updated with new data so that a historic legacy value can be built and improved on over time, increasing your knowledge. The unique combination of the Raman spectrometer and TranSpec software produces many benefits. These include significant savings in time and cost due to the rapid turnaround for results and the minimal maintenance requirements. The portable nature of our Raman spectrometer means on-the-spot analysis can be done rapidly wherever it is required, whether it's goods in, production or outgoing materials. TranSpec is not limited to a single measurement. It can look for multi-components and properties, again improving efficiency. Because our Raman spectrometer has adaptable probes, the ability is also there to do both near-line and on-line measurements, without the need to destroy materials or carry out lengthy extraction techniques. What you get is the actual concentration at the point of contact. The unique way in which TranSpec works means that it can give rapid results without being limited to single measurements. Qualitative or elemental analysis like XRF or FTIR, or even Raman without TranSpec software, may be rapid but cannot give that extra level of knowledge. It also has the advantage over other quantitative methods such as chromatography based methods in that it is rapid and non-destructive, or requiring preparation. TranSpec Raman consists of a portable Raman spectrometer that weighs less than 3 kilograms. An optical fibre links this to a handheld probe, which could be adapted to fit into processing equipment such as an extruder head, and there are a number of attachments that can be used dependent on exact sample types, such as a spinner to give an averaging over an area. The spectrometer is run through TransChem software. Again, there is adaptability here where a pocket PC could be used for routine analysis. Utilising cutting-edge Raman technology, TranSpec can offer a variety of features such as rapid analysis, typically seconds, high molecular discrimination, allowing additive analysis from 0.1 to 100 weight percentage, with no moving parts or preparation of samples required, thus it has low running costs and maintenance. Our unique software package means multiple additive measurements can be made in the same measurement, as well as ability to predict properties, and for routine measurement, the point and shoot method requires no specialist training. The flexibility of it means that it can be both portable and used near-line and online. An attraction of TranSpec is that it can be easily tailored to your needs. The probe can be tailored for solids, liquids, to look through glass, and adapted to fit into processing kit. The method can also be tailored so that the setup is optimized for your materials. The next step is to tailor the analysis. The analysis uses your specific data and correlates to the parameters of interest to you, with the reporting format tailored to that which is required. The adaptability allows TranSpec to be used throughout the value chain. This includes raw materials, pelletized materials, in-process, finished products, and end of life. The applications of TranSpec can be throughout the value chain, offering quality control of incoming and outgoing material, offering quality assurance methods for near-line and online monitoring of production, which in turn can be used for customer certification as well as compliance with legislation. TranSpec can also be a very powerful tool for formulation and research support. With valuable databases built, performance can be related to formulation and knowledge can be accumulated, and trends identified. IP policing and protection is another application of interest to the industry. Within these types of application, the typical analysis is qualification through identifying the materials, then quantification, typically concentration of additives, with further analysis of dispersion issues related to the uniformity of the materials. The ability of TranSpec to correlate spectra to the property means that the ability to predict properties exists. This could include process properties such as melt flow indices, thermal properties such as glass transitions, physical properties such as mechanical strength and density, as well as fire properties such as UL scores and LOI. For TranSpec to make these types of measurements, we must first build the models. This requires a known calibration set, typically a range of concentrations of a formulation of interest. These are then scanned and the information such as concentration and properties can be easily entered. The spectra are then compared and a calibration model is produced through the software. The following is a quick run through the steps in TranSpec to enter new samples into the database and to give a view of the TranSpec software. First, we select the advanced mode as we are building new models with calibration samples as opposed to routine work. At this stage, we scan the sample. The system is set up to automatically optimize the quality of the spectra. Here we see a spectrum of melanine cyanurate in nylon with glass fibre. This typically takes around 10 seconds to collect. The next step allows all the information required to be entered about the material. In this shot we are adding the type of FR as melanine cyanurate and then the concentration as 2%. But any data of interest can be added at this stage and then stored. This step can be easily repeated to enter other samples for the calibration, and once you have collected the data required, we move on to the model building. Here you see a typical Raman spectra of 3 different polymer types. TranSpec uses all the data contained in these spectra. Our software then regresses all the spectral information and builds the models. This is an extremely powerful analysis designed to find correlations that cannot be otherwise spotted and is a unique feature. Here we can see how the software can place material types into groups. Each point is a single sample, and from there it is possible to split the polymer types into the groups. Then, within these groups, we can see a model TranSpec has built on the concentration of a flame retardant within that matrix. This is then validated and can be used on unknown samples. Gnosis can carry out this model building step for you, or you can do it internally with some basic training with the software. Once a model is built, the routine analysis requires only a very basic training. Now that we have a model, the next step is to set up a solution. For this webinar, we have chosen to measure the concentration of melamine cyanurate in nylon. We then pick the model we have previously produced and choose what properties we want to measure and save this as a solution. In this case, we are looking to pick melamine cyanurate as the flame retardant, and we want to look for the concentration. Once the solution has been designed, we can select a solution to carry out in routine analysis. TranSpec software talks you through the steps required. After just a couple of steps, we are at the results page, showing a sample measured to be a 6% melamine cyanurate in nylon. Other solutions can easily be set up. For example, a QA method specifically set to meet a specification. In this example, a brominated flame retardant FR1210 in a concentration range between 1.5 and 2.5%. Here we are on a QA mode results page. We have a traffic light system in this example. A red light means specifications have not been met. In this case, TranSpec has identified the wrong FR is present and the concentration is outside the specified limits. All of these parameters can easily be set up when designing a solution.